Alright, this is chapter 25, number 19. A company institutes an exercise break for its workers to see if it will improve job satisfaction, as measured by a questionnaire that assesses worker satisfaction. Scores for 10 randomly selected workers before and after the implementation of the exercise program are shown in the table below. Number A, identify the procedure you would use to assess the effectiveness of the exercise program and check to see if the conditions allow the use of that procedure.
Okay, so for A, the name of the test is a paired sample t-test, and you have to check the conditions, which are you have to make sure if it's paired, the workers have to be the same before and after. And then it has to be from a random sample. It has to be less than 10% of the population. And you have to draw a box plot showing the difference in job satisfaction, and that's what we have right here. And then it's symmetric with no outliers.
B, test an appropriate hypothesis and state your conclusion.
Okay, so our hypothesis, our null hypothesis was the average difference is 0, and then our alternative hypothesis is the average difference is greater than 0 with an alpha level of 0.05. And then you plug the chart into your calculator, into the L1 and L2, and then for L3, you subtract L2 from L1, and then you go to second distribution, and then you go to 1 bar stats. No, that's a lie. You go to stat, and then you go to 1 bar stats, and then you get your mean is 8.5, and your standard deviation is 7.47. And then you plug it into your t-score value, which is the average difference, which is really the average, minus 0, because that's what's in your hypothesis, and then over the standard deviation, and then, or the standard error. And the standard error is the standard deviation over the square root of n, and n is 10 because there were 10 people participating. And then you plug it in your
You need to find
t score, and you need to find t, and so it's 8.5 minus 0, because that's from your hypothesis, over the standard error, which is 7.47 over the square root of 10, and then you get 3.598 or 3.6, and then you come over to your p-value, and you write out p, parentheses, t is greater than 3.598 or 3.6, and then you go to your calculator, and that's when you go second distribution, and you go to TCDF, and then you plug in 3.598 from here, well actually from here, and then 99, and then 9 for your degrees of freedom, and then you get 0.0029. And then the conclusion is, due to such a low p-value, we reject the null hypothesis, meaning average job satisfaction has increased after implementation of the program. And then for part C.
If your conclusion turns out to be incorrect, what kind of error did you commit?
Okay, so if that's incorrect, we committed a type 1 error, and that's because we rejected the null hypothesis, but we shouldn't have.